Thank you.
Okay, so thank you for the introduction, Professor Isaac, and a very good morning to one and all present here. So as Professor has already introduced me, I am Deeksha and I'm a faculty member at the University of Tokyo, Japan. So the topic for today's presentation is roadside building facade observation using dashcam imagery. So before coming to this topic, let me first introduce you to the authors and our main research project so that you can get some background information of why we chose this topic and what we are doing for this particular research area. So apart from me, there are two other authors, Dr. Hiroya Maeda and Dr. Yoshihide Sekimoto. So both are associated with University of Tokyo, and additionally, they're also the founding members of UrbanX Technologies, our industry partner for this particular work. And our main research is AI-driven global road damage detection. So we started this project almost a decade ago. So as you can see, in 2018, we proposed a solution for automating the road damage detection for Japan using smartphone images. And these images were captured by mounting the smartphone on the dashboard of a vehicle. So this was for Japan. Then in 2020 or in the later years, we extended this work globally. So in the recent Big Data Cup that we organized, 2024, we have extended it to 6 countries. So during this process, we release several open data sets. So if you are working on a similar project, you may explore the RDD data sets, which has large scale images, annotated images using road damage instances from multiple countries. And in terms of performance using this data set, so you can see in 2018, the performance was only 65% for Japan. But when we extended it to 6 countries and we had multiple solutions, now the performance has been improved till 86% F1 score. So if you are working in this area or if any of your students want to explore, then please refer to these datasets or the Big Data Cup competitions where we invite researchers from all over the world to propose their solutions using this dataset. Okay, now coming to our main topic. So since we were already working on road damage and road image data, so next we shifted to roadside buildings and specifically roadside building facades. So let us see why this is important and what we have done in this area. Okay, so before I come to our research, let me first ask you, how many of you like this kind of glass facades? Would you like to have it in your homes or in your office buildings or anywhere else? No? Okay. No? Okay. Any yes? Okay. Okay. So we may have different arguments. Some people may like it, but, or some may not like it. But when we look at it from the perspective of planning a city, then we need to consider different aspects of it. For example, some people may argue that it will help in saving energy during daytime because lighting is automatically enabled. But then another argument may be that it will contribute to greenhouse effect and ultimately to global warming. So we should not have this kind of building facades. Or there may be many other arguments in the favor or against having such kind of facades. So to consider all those aspects, we first need to have some information of what kind of building facades are there in our city, in our country, or in the whole world, so that we can design for whatever our requirement is accordingly. Okay, so we can say that facades shape street level enclosure, pedestrian microclimate, as well as the environment exposure. However, when we look at city scale data sets, there is usually a data gap that most of these data sets consider only information like building height or footprints and ignore street level visibility. Now, some of you may say that we already have street view images. So yes, it bridges the gap in some cases, but it still has certain challenges. So let us have a look on what are the challenges. So for street view images, the literature has shown that the coverage of the data is uneven. So usually it doesn't cover all the streets or all the roads in the same frequency. So it is usually biased or incomplete. Then most of the existing studies which have considered this kind of street view images or their collected data, they usually assume that the facades are clearly identifiable in the image, just like we had in the last image. However, there may be certain dense contexts where the facade may not be clearly identifiable. So we may have intermixed facades when we look at it in the image view. So considering those cases, we address the following research question. So for facades that are captured in the image, we need to check how visible are they and how should they be recorded so that we do not mistake the observation as the precise or complete measurements. And the approach for achieving these objectives is to use dashcam-derived imagery in dense Tokyo streets as a test case. So in the later slides, I'll be presenting how we performed the experiments using dashcam-derived imagery. So this is some information about what data we used. So this was provided by our industry partner. So it has around 506 annotated images. Just like this, if you look at it, all the building instances are annotated using bounding boxes. So the annotated data looks like this. So there are multiple building instances in each image, and we have annotated them. Then coming to the method. So for roadside building observation, we consider a 5-stage pipeline. So we start with collecting the data using dashcam and GPS, and then we extract the frames from the videos. And on these frames, we apply our building facade detection algorithm. So we have trained a YOLO V8 object detection algorithm. You can replace it with whatever latest version is available, or if you want to have any different architecture, so that doesn't matter. But the purpose is to detect the building facades present in the images. So right now we are considering only a single class of building, but later we can have multiple categories of buildings, say glass facades or different kind of facades or different kind of purposes. Then once the facades are detected, we may use some kind of depth estimation algorithm. Like in this case, I have used depth anything algorithm. And using this depth information, the GPS and the detected facade, we can then perform map matching to plot whatever facades have been detected on the map level or on the city level, so that we can get a document or a database for the whole city. Now let us have a look on the results of the building facade detection part, because that is what we are covering as the main part of our approach. So the results shows satisfactory performance of having a precision of around 80% or more than that, and recall of around 72%. So since we were just performing some experiments, so it is satisfactory at that level because we did not apply any kind of optimization. However, when we look at the details and perform visual inspection of the predictions, we realize that most of the detections include multiple facades or overlapping facades. So you can see the bounding boxes are overlapping. So it is difficult to identify if it is detecting each facade clearly and as a separate instance, or is it intermixing? And the same pattern was observed in both of the algorithms, like YOLO V8 version S and version N. So that means we inferred the ambiguity is in the scene, not the detector. So considering that, we performed further analysis and inferred that the challenge in facade level analysis is not the detection accuracy, but how visibility and building boundaries are defined in dense streetscapes. So that becomes our central question from now on. And we reframe our motivation. So we started with facade observation, then shifted to facade detection. Now we are looking at how to document the interpretive conditions. So let us have a look on what kind of ambiguities did we notice in the annotation analysis. So if you look at this image, you can see there is an occlusion by a moving vehicle. So in these cases, the annotator need to decide whether they should cover only the visible facade or the inferred boundary. So that becomes a question of the annotation decision. Then in some cases, it may be difficult to cover only a single building in the bounding box. So for example, in this case, we may have two types of boxes, either to capture the complete building in one box, even when we are covering some part of any other building, or we can capture only one building in one box, even when some part of it is missed. So we need to fix the annotation rules accordingly. Then there may be cases where the street furniture may block the view, or there may be extended built up. For example, there is a balcony. So should we cover that as a part of facade? In some cases, you may have glass applied to balconies as well. So we need to take that kind of decisions. Then there may be cases where one box covers multiple buildings, and we cannot clearly say which of the building is it referring to. Or there may be parked vehicle occlusion, or there may be cases when single box cover multiple instances of facades which were differentiated using different depth. So that means we need to incorporate depth information in our analysis to have a proper documentation. And there may be cases when the building visibility is very low. So that means we need to have some kind of threshold, like how much visibility is required to include a building facade in our database. Then in these cases, there may be multiple buildings facades at different apparent depths. So we need to fix up to how much depth do we want to cover the facades in our database. So similarly, there may be some other cases where the buildings are only partially visible. And based on this analysis, we propose a metadata annotation framework so that we could record all these observations while annotating the building instances. So these are some of the fields. So we should have visibility level, extent drawn, or attached elements, which could record the basis which was used by the annotator while classifying or while deciding the bounding box of any building facade. So that was most of the work that we have done. And coming to the conclusion, so since we wanted to explore the feasibility and the challenges, so we concluded that yes, it is feasible if we are using dashcam imagery to observe building facades. However, there are certain challenges. For example, in visibility, where there may be occlusion in the view, or in interpretability, where there may be ambiguous facade boundaries. And to address these, we contribute a metadata scheme that could be combined or integrated with the modeling or the training model that we were using. So the future scope includes how we integrate that metadata with the model training so that we could quantify or analyze the exact impact of using this kind of metadata scheme. And in the long run, we could also test it for multiple cities, and we can actually see using map matching by having multiple categories of buildings. Okay, that was it. Thank you so much. And this project is...
Thank you very much.